welcome everybody. Hello, nice to meet you. So yes, a long time ago, it was 14 years ago, in a conference center far, far away, we had some JVM wars. It was a dark time. The sun had been destroyed. Java was weak and being pursued across the galaxy. Away it goes. So that's the thing. We had this time, September 2010. It was a long time ago now, in San Francisco. And really, what I'm doing today is re-examining what I talked about in 2010. You know, what was this next big JVM language concept? Did I successfully predict the future in my Jedi Master Joda? If you're Dutch, I believe you say Jedi Master Yoda, funnily enough. And what anything that they can teach us now in terms of the languages. And this is an opinionated talk in places, you know, I might not always say what you like. It's all right, you're allowed to criticize me. So who am I? So I'm the author of Joda Time, Joda Money, Joda Beans, Joda Convert, also the Java Time packages within the JDK. So for many years, I was a regular blogger and speaker, taking a back seat in the last few years with young children coming up. And I've used a fair set of languages. So I started on BBC Basic. So not all of you will know about the BBC, but that was the standard computer in the UK. Not very much memory, wonderful graphics. But yeah, that was quite fun, and you even did some assembly language processing on there. My first job started with COBOL. So you had this gigantic room that was probably bigger than this room we're in here, full of a mainframe computer. You had to submit your jobs. You had the grand total of 8 characters for your program name, and the first 4 characters had to be your username. So you had a grand total of 4 characters for your actual program name when you were running it. It was a very different world back then. AM, that is Applications Manager, which is a 4GL, or was a 4GL, because I can't find any trace of it whatsoever on the internet now. It was a rules language. Everything in it was entirely global state. There was no scoped variables in the entire system, and we built gigantic systems in it. That was fun. And then perhaps more traditional things with Java and JVM bytecode after that. So yes, you can't stop change. So, of the people in this room, so how many of you were coding in Java in 2005? So more than I might have guessed. So there's a fair few old timers here. That's how I think of myself anyway. So I've kind of divided up Java timeline into sort of 4 separate things. There's the initial growth phase. So in that initial growth phase, it launched in 1996, and it just had this amazing growth and adoption initially. It was just like this curve that went up and up and up. You think there's lots of people at this conference here. In San Francisco, you had Java 1 conferences with 20,000 people in them. Right? This is a town attending one conference. The line to get into a room would be like stretching from here all the way down the stairs and all the way around to the food zones downstairs, right? And people with giant paddles to route you to one place or another place. These were huge conferences, and they were it was the center of the whole tech industry at the time in many ways. And you had these regular releases, and the adoption grew and grew and grew until it didn't. So fundamentally, what happened was some microsystems, who were the ones who created Java, they were going out of business. So some microsystems' business was to make hardware, Spark boxes, and those were eaten alive. So those boxes were eaten alive by Intels and Pentiums, and their operating system was Linux and Windows NT took over from it. So the company was just, you can see from the chart, losing money hand over fist. So unsurprisingly, there was no real money to invest in Java. They knew Java was valuable because they renamed their stock ticker from SunW to Java. So they really knew it was valuable, but they couldn't do anything to kind of stem the tide. And Oracle came over after a bit of a fight as to who'd take over. Would it be IBM? Would it be Microsoft? Would it be Oracle? Who would it be? It was Oracle in the end who did the deal. So when Oracle took over, as happens when you have these kind of situations, many senior engineers left, many projects were abandoned, and many people kind of thought that Java was that most important bit. Oracle decided to sue Google over the use in Android. Probably wasn't the wisest move in ever. In fact, I called all the parties in that debate dumb, dumber, and dumbest. You can decide who was which. But releases were still slow. Even after Java 8, releases were still slow. It wasn't really until 2017 when we had Java 9 and the modular Java completed. After that, we had these 6 monthly releases, and really that's the point at which Java was back on track. But it was much more of a focus on core. EE and FX and so forth had disappeared. So there's the timeline. It's probably too small for you to see in great detail. But I've highlighted in a sort of brighter green as sort of the more important releases. We'd call them LTS releases now, perhaps, and the minor ones in between. So, you had 1.0, you had not much in 1.1, then 1.2, or Java 2 as it was known at the time, just to be confusing, that was really the beginning of Java being a properly usable language that people could widely adopt. You roll forward a few years, you got Java 5. Again, that was a real baseline release which people could widely adopt. But then you can kind of see how it peters out. People were going, well, Java 5, those generics, we didn't like the erasure. We're not really convinced by it. Are you really getting it right now? Could there be something else out there? Could we do better? And entered alternative JVM languages. So it's interesting to look at the timeline. It was where people started having doubts about Java is the point at which these alternative languages came in. So you can see Scala being early Groovy, early Clojure, early Phantom. So these languages came along and they all kind of reached their sort of sensible 1.0 point roughly about the same time. And that is the point at which I did my first talk. Now, it wasn't until I actually wrote the talk that I realized this is kind of halfway through the lifetime of Java. So, we've had effectively 15 years before my talk and almost 15 years after my talk. So it's interesting to kind of go back and revisit what's changed since then. Because that's what I was looking at. I didn't know what was going to happen in the future. Go back. There we go. So that was the peak time for languages. It was great. There were other languages out there. Gozu was a language which I could have included in my original talk. There wasn't a Kotlin or a Ceylon or an Extend or any of those languages at the time. Even while I've been here, we've seen some new languages which I hadn't spotted before. BBJ and Rockstar have been mentioned at this conference as being some new and different languages. It's a very flexible platform for building languages on. So the question I have to ask is, what is a big language? Well, it's a key dominant language. It's widely used. There's this huge job market. It's got ecosystems around it. It's got community around it. I think we kind of sort of know what those languages is. And sometimes our favorite language, we want to be one of those, but actually it isn't. So I'd say these are or have been big languages. Right, really top ones up there that you could go and get a job in, that you could be safe, that things were going to be out there in them. Nobody's going to argue about the ones on the left. I don't think most people argue about the ones on the right, but these days, maybe Perl doesn't really fit on there. Maybe Ruby doesn't really fit on there anymore. That could be controversial. But since 2010, there really haven't been that many languages which you might choose to add to that list. Go, perhaps. TypeScript, probably. Rust, maybe we'll get there in a few years. But it's surprising how sort of settled it's been in many ways over those past years. So the definition of the next big JVM language was the language that will challenge Java and displace it on the JVM. So why was Java strong? Why was it a big, important language? So the original design goals of Java, called Oak when it first started, you look at them now, they still make sense. You've got this simple object-oriented familiar language, i.e. it was familiar to people who were already coding at the time. robust and secure. So it was kind of designed for sort of the Internet of Things before there was an Internet of Things. So some of these principles mattered there. Architecture neutral, you wanted to be able to run on all sorts of different platforms. High performance, that's kind of always a thing in languages, but interpreted and with threads. So it started from C++, fundamentally. There were other influences at the time. It simplified. So you took away some of the redundancy, some of the complexity. It tackled the bug hotspots that you saw in C++. It raised the abstraction level. So it wasn't that low-level systems language. It was a next level up language. But it wasn't too scary. Like if you knew C or C++, the syntax wasn't surprising. In fact, even today, you can put your array brackets in the C location. Go look it up if you've never experienced it. But you don't have to do string array. You can put the array in a different location on the line. And applets were a big thing. It was one of the key drivers for the language. Until people figured out they weren't very safe and secure and there were better ways to come about it. But at the time, applets were a key driver. So there's a long list of things there. So all these are things that Java didn't have that C++ did, i.e. there's less things there. Does that not mean it's worse? Fewer features equals worse, right? But actually, you go through the list and you go, well, that surely was a good decision. A good decision you didn't have variable size primitives. It's a good decision you didn't have buffer overflow. I think it was a good decision we didn't have unsigned primitives. Occasionally we get annoyed by them. Did we really need a preprocessor and headers? No. Multiple inheritance, well, that was just a pain. Operator overloading, yeah, we've suffered from not having that quite a few times. But lots of good stuff that was omitted. And virtual machines themselves, the JVM, wasn't a new idea, but fundamentally the JVM repopularized it. It made it something that people really wanted. And this WORA, write once, run anywhere, that was a big thing. It was something that you got hammered on if you were engaging in any forums or conferences. It was like, we must be write once, run anywhere. We don't want any native code. It must all be Java. The safety stuff, good again. And garbage collection, well, that was a huge step forward. I mean, it's interesting hearing the talks today about Rust, which is taking another step in a different direction from memory safety. And now we've got, so you've got sort of the Java model and the Rust model. They serve different purposes. They're not competing. These are languages that serve different purposes. But yes, less, not more. Java wasn't adding on more features to what went before. It was taking away. And if you did a checkbox comparison of the two languages, you'd always choose C++. But that wasn't the point. Because a mainstream big language is fundamentally defined by productivity. Productivity is the thing you want out of a language like this. Java got lots of stuff right. It was a productivity revolution fundamentally. And yes, we can criticize it with hindsight. And I criticized it with hindsight 15 years ago, and I can still criticize it with hindsight 30 years ago now. But it was a big step forward, and it is still enterprise language. It's the one that people use. So you had this thing, evolution and revolution going together as you went from C to C++ to Java. And yes, they're nothing without their community. Excuse me a second. Who are passionate adverts for the language. Library authors, massive community of people. So I mean, like this is Devoxx conference, which descends from the Devoxx conference in Belgium, and that descends from Javapolis, which started in 2002. So there's a long history of these kind of conferences out there. So a quick look at some of the problems that we've had, taken with a 2010 viewpoint. So some of this judgment was historical. We can look at that with hindsight. We can look at it with really well experience. Things that were good choices in 1995, not good choices now. They might have been good choices in 2010. Things change over time. Language design changes over time. So these are what I listed in 2010. Whether I'd list the same ones now is a different matter, but I would put checked exceptions up there. Basically, no other language does checked exceptions. Java was fundamentally taking good ideas and throwing away bad things from C++, and yet it put checked exceptions in, which was novel and new and hadn't been done elsewhere. Now, there'll be some people in this room who really like checked exceptions, but the fact that nobody else has adopted them is a clue that they're not a mainstream thing. They're not a fundamental concept. Primitives. So why are primitives in Java? Because otherwise it would be too slow. Computers in 1995 were not fast, right? The sole reason why we have to deal with primitives is because of that. If you were designing a language today, you can put an object representation of a number and have the compiler sending down to be a primitive underneath the scenes if you want to. But that wasn't possible at that time. Arrays. So again, arrays are fundamentally a performance thing. The fact that we have these arrays that are exposed, they work differently with regards to generics and variants. They're a bit of an oddity, but you kind of need them to make any kind of sensible data structures. So yeah, they're a bit odd. So everything is a monitor. Well, this is about basically saying that every single object you create in Java has associated with it a monitor, a flag, a something that you can synchronize on, that you can lock on. But what proportion of objects in Java do you ever actually synchronize on? It's tiny. It's infinitesimally tiny. And yet every single object has to carry that cost. Now, this is what Valhalla and value types is trying to tackle now and trying to take away this problem. But this was a known problem that was slowing down Java and preventing optimizations in Hotspot. So had that decision not been taken in 1995, we would have faster JVMs now. That's just how it is. Static. Nothing wrong with static per se, but there's no way to treat it as an interface, no way to treat it as an object. So you get lots of factories, you get shared mutable state. So there were various aspects of static that were potentially problematic. Method overloading. Now this is an interesting one that I pulled out that other people probably look at me and go, that was an unusual one to say. I quite like method overloading. It's quite useful to be able to have multiple methods with the same name and different signatures. But it does make it harder for the human to reason about and for the compiler to understand. As we will see later on, there are alternatives that deal with this now. And there are other languages out there that get away with no method overloading at all. And if you don't have any method overloading, you don't have overloading between methods and fields, then you can just refer to the field or method in reflective code just by its name. And that's really powerful. And generics. This was after Java 5 had just come along and everybody was going, oh, generics and the erasure stuff, and I don't really want erasure. It's not really what I wanted. The fact that it was fundamentally the backwards compatible solution was just how it was, but it didn't make anybody terribly excited about it. And the other aspect which we had was that Java being backwards compatible, that was a key part of why it was successful, affects how easy it is to alter the language, how easy it is to change that language. So yes, it's not 100% backwards compatible, but it's pretty close. If you can find a Java library compiled with 1.0, it will probably still run on the JVM today, which is pretty impressive. But yes, it means it's very widely used. So it's really hard for a change to break existing code. And any changes need careful thought. So the theory was, if you have a clean sheet language, it should be much easier to change. In particular, those 5 features, arrays, primitives, varargs, method resolution, and checked exceptions, are ones that did influence or restrict the ability to change. Like, for example, in lambdas, which we eventually got, checked exceptions was a problem. In the end, the solution was to just ignore them. Right? So everything, primitives has been a problem, like with the functional interfaces we have, function and predicate and consumer. The solution was to make some primitive sub-interfaces of those. Not a great solution. But the point was that if you've got 10 million developers using Java, any change you can make that is positive in productivity terms is good, because that benefit applies to so many people. As a whole community, as a whole programming world, it's a huge step forward. And so there were some step forwards. Try with resources, multi-catch, not big ones. Java 7 wasn't massive. but it was stuck. Java was stuck at that point. So people were going out and finding new things. So we had this thing. We wanted to basically say, we want, the next big JVM language. We wanted to keep the good parts we know about Java. We want to evolve it, but also have some revolution out there, learn what we've done, and also design for the right target audience. This was the test I put forward. So take a piece of code in this new theoretical language that we're talking about, NBJL, just a sensible piece of code, nothing too fancy. You give it to a mid-level developer, and can they understand it? Like with no tuition and no documentation, can they take a reasonable stab at what the meaning of that code is? That seemed like a good starting point for a target audience test. And this was my attempt at doing a beautiful diagram as to how the world looks, right? There's lots and lots and lots of developers who are focused on business value. And there's a small number of developers who are evangelists or sellers or people who go out there and promote some new technology. Now, in fact, that's not to scale. I mean, like the size of that yellow circle should probably be as big as this conference center, right? The proportions of that are out. So where does a language designer sit? Well, language designers are very smart people, like very smart people, right? And their comfort zone is right on the end of what those evangelists lead, right? The real alpha geeks of the world. That's where a language designer feels comfortable. But what you need is a language designer who is comfortable finding that special point where evangelists are comfortable with the language, but actually so are everyone else. So it's a tricky problem you got there. So you wanted this to be a blue-collar language. You wanted it to be for everyday use. It's not going to be exciting. It's not going to be pure. It's not going to be academic. It's just collecting the good ideas that have come along from other places. And yes, it has to be written by a language designer, which is tricky. So I suggested some of these things would be what we might see in it. You might see a curly brace language. At the time, curly braces was definitely dominant. In the last few years with the growth of Python, perhaps that isn't the case anymore, but there's still an awful lot of curly brace out there. Would it be object-oriented or would it be functional? Well, here's the amusing part about what Java thinks of itself. Java has no functions. Object-oriented programming supersedes functional procedural styles, and mixing these two styles just leads to confusion, dilutes the purity of OO. Anything you can do with a function you can do by just defining a class and methods, and by eliminating functions, your job as a programmer is immensely simplified. And that is from 1.0 Java. That is what was written when Java first came out. Now we can look at that now and go, well, that's not what we think anymore. But that was when it first came out. It was about OO. It was a very OO language. That was the focus of it. Of course, the Smalltalk people laughed and knew it wasn't anything like OO, but hey. So Java is less pure than Smalltalk, but then pure functional programming hasn't crossed that bridge into widestream appeal. It's going, it's gained, but pure functional programming hasn't crossed that. People really want practical features and not paradigm wars. They're not too fussed, so long as it allows them to do their job efficiently. Remember the giant yellow circle? That's what people care about. They just want that productivity. What about typing? Static versus dynamic? Well, this was the view leading up to 2010. Static type systems had been in decline. There was sort of perhaps a hint at the end that maybe they were going to recover. At the time, it was like, Ruby is 10 times more productive than Java. You must move to Ruby. It's so much more productive. It doesn't have any of these static type rubbish. But we look at it now, with the extra 14 years of history, Groovy has added type systems. In fact, loads of the other languages have basically added some kind of static typing or optional typing. So I don't think this is really a debate anymore. I think static types are seen as a really key thing that a programming language has and can make use of. So yes, I suggested it would have a static type system. Reflection, well, you wanted that counterbalance. You wanted to be able to have dynamic behavior. Java's reflection is a bit painful. It'd be nice if it was better integrated. Beans, well, nothing's happened on Beans in another 14 years. They're still poor. They're still a bit rubbish. You can do better than that. Yeah, I use Joda beans. Some people will use Lombok. Some people use immutables. If you're sensible, you need to use something more than just writing getters and setters with your IDE. So this was a time in 2010 where 2009, Oracle had basically officially said, we want to do closures in Java, but we don't really know what. And it took them ages before we got to Java 8 and actually had them. So although the idea was out there, although people were discussing it, there was no real faith it was going to happen. Function types. I suggested at the time that we might have function types. Now Java's got SAM method types, so we convert them to functions and predicates and so on. Perhaps function types don't fit Java, but most other new languages are coming out with function types. Null. I'm sure most of us think of null as being a pain that we don't really want to have. So, you know, ultimately, they're not too much of a problem so long as you can control them. Kotlin's kind of shown that. So there are ways you can deal with these things. And concurrency, well, Java already had threads, you know, but the programming environment changed. Suddenly you had all these multi-core CPUs that were coming out. And these concurrency issues that didn't seem problematic when Java first came out suddenly became real. You actually started to have these problems of clashes going on and race conditions, all the rest of it. The world changed. And so the libraries did change. We did get better libraries to manage concurrent stuff. But you know, maybe fewer people write concurrent code than you might imagine. You know, in a web server, fundamentally the clever person who writes the web server writes the concurrent code and you just deal with a request. Providing you deal with your request on one thread, you kind of don't care so much, right? Modules. So people Java had been talking about having modules for years and years and years. You know, didn't actually finish until 7.5 years after 2010. It took a very long time to do. Yeah, reality is that modularizing from the start is a huge benefit. Lots of other things that you could do in a language. It'd be nice if the language included its own tooling. It'd be nice if it had more literals. So this was a long shopping list of stuff I was putting out there. That's just 18 things. You know, expectations of a programming language advanced. We want more features now. But then I'm conflicted by the fact that actually you go back and look at what Java did, it took features away. It was worse. So there's a conflict there. It's an interesting tension. Faith. So 4 new JVM languages that I evaluated at the time. This was a conference talk. Limited time to do proper evaluations. So did any of these JVM languages match the description I've just given of a reasonable outline of what a big JVM language that would appeal to that gigantic yellow group would appeal like? Clojure? I mean, I've just gone through the list of features, the kind of person it needs to be attracted to, the kind of things it's going to want to appeal, the kind of features it needs to have. It's not going to be Clojure, right? Now, that doesn't mean Clojure is a bad language. It doesn't. It's a very clever language. It's brilliant. It's got, you know, written by a smart guy. You know, some new stuff with software transactional memory. But it's not. It wasn't ever going to be that big language. It wasn't going to break through and become what was going to be a Java replacement. Doesn't mean it can't be big enough on its own to sustain its own community, but not enough to replace Java. Groovy? Some people think that's harsh, perhaps at the bottom there. Fundamentally, Groovy is, you know, here's all the syntax from Java, you know, but we got a dynamic type system. Obviously, you can now actually add static types to Groovy, but that wasn't the case at the time. It had performance issues back then, which it doesn't really have in the same way now, so long as you use static types. But had it moved forward enough? Was it beneficial enough for a Java developer to think, I'm going to be more productive by moving to Groovy? Not enough. There wasn't enough stuff that would make that difference, that would make people make that step. So I ruled it out. Scala. Yeah, it has that goal to be scalable from small systems to large systems. Has this static type system? Well, that's true. OO and functional hybrid. Well, I said that was probably going to be the case. It looks a bit like Java. I mean, yeah, reverse types, not a huge deal, right? So perhaps this could be the Next Big JVM Language. So here's what I found sort of on the overview paper launched at the time. It fuses object-oriented functional programming language into a statically typed programming language aimed at the construction of component systems. This paper gives the overview of Scala language for readers who are familiar with program methods and language design. So it came from an academic background, right? Why did Scala become popular? Why was it noticed? Because Twitter decided to use it. And if you listen to some of Martin Odersky's talks, he'll say that our language suddenly started peaking when Twitter adopted it and every other company wanted to be like Twitter. Only thing was, Twitter only had 26 engineers at the time. It wasn't this giant, huge company. It was very famous. People imagined it was a huge internet company with loads of staff, but it wasn't. So there was a bit of a interesting thing going on there. So my judgment was, no, it's not going to be the next big JVM language. So this 2010 judgment. There were all sorts of arguments going on internet forums back then, and to be honest, half of them still exist today, as to, Scala is complex, Scala is not complex. Scala is wonderful, Scala is terrible. It's divisive. There is a divisiveness about Scala. Community there, it may be an OO functional hybrid language, but that's not what the community adopted from it. The community adopted functional programming from Scala. That's why they chose to do it. Implicits, they seem to be too magic, they seem to break too easily. That's the feedback you get. And unfortunately, it genuinely did have terrible backwards compatibility. You had to all the library authors had to recompile their libraries against the next version of Scala. And that meant you got a breaking ecosystem, every year or so. Wasn't great. And then to cap it all, in the end, people started talking about once they had large Scala systems that actually it took a long, long time to compile. So it wasn't a wonderful situation to be. And that was the judgment that I and others were making of Scala. But at the time, you had to be quite brave to criticize Scala because you got a lot of flames back. The proponents of Scala at the time were very, very strong about what they were saying. So roll forward 14 years, I think we can say that Scala has found its niche, right? It is out there, it is being used, it is a practical general purpose programming language that there's a group of people who actually really value that, and it fits well on the JVM and achieves a lot. Now, having looked at it, not played with it, but having looked at the online examples, Scala 3 does seem to be a step forwards. This focus on having backwards compatibility at the heart of the ecosystem by having it at the heart of the compiler, that seems to be a really good step forwards. The ability to migrate code automatically between various Scala versions seemed like a good choice. Whether dropping curly braces is a good choice, that's a slightly separate question. It's still the same power, perhaps even more power now. So the thing you have to be careful of is, if it's great for you to code, and it's great for the next person next to you to code, but are you actually coding the same Scala? Are you working together? Have you got a good set of code guidelines or approach? Are you all of the same mindset for what subset of Scala you want to be using and how to approach problems? If you can address those issues, I think, from what I can see, you can be pretty productive in Scala. So I still don't think it's the next big JVM language. Phantom. Has anybody here actually heard of Phantom? There you go. So Phantom I included it, nobody had heard of it much back then, but I included it because it's much more radical in many ways than the other three languages we've talked about. It was neutral between the JVM and .NET. You actually compiled Phantom to a format called Fcode, and then Fcode was interpreted on both the JVM and .NET. It had a completely independent set of libraries, so it had its own set of core libraries. You could use Java libraries, of course, but it had its own core set of libraries. It was OO with functional. Null was a fully handled part of the system. Its syntax wasn't that dissimilar to Java. Maybe it could be. And this was another reason why it could have been. Designed as a practical programming language to make it easy and fun to get real work done. Oh, that word fun's in there. That's interesting. It's not an academic language to explore bleeding edge theories, but solid real-world experience. So it was addressing the right target market in the right way. And I still think, even today, it's an amazing language. Do I think it's going to be widely adopted? No. But I do think it's an amazing little language. It has very sensible basic features. It has null handling, operator overloading, but not free-form operator overloading, controlled, and a whole slew of unique features that we just haven't seen anywhere else. So by being 100% modular, you have just these 3 levels. You don't have like modules, then packages, before you get to types. You just have pods. And pods are modules, but they're also packages. They're also the thing you deploy to Maven, to like the equivalent of Maven Central. So you have this thing where you can refer to any particular pod or type, class, or method just using these 3 things. So you have a unique reference globally to a method or a field by a straightforward 3-layer thing. It's amazingly powerful. Reflection is really easy because you can just use the name. You don't need to clarify it by which parameters you're passing in. Trap methods, method missing, you might know it as, in Ruby I believe it is, allows you to build DSLs which capture method names which you pass in, which you don't know about up front. It comes with a build system, with a central repository, with built-in testing, with built-in logging. You don't need to go out and get libraries for all of these things, as we do today. You have to import JUnit, you have to import SLF for J. It had all of that built in, but had no generics, fundamentally. There was a list, and there was a map, and there were functions. Those were the only thing you could actually do any kind of generics on, and that was all built in. No shared mutable state. The language knew about immutability. If you wanted to talk to another thread, you had to send an immutable message across to the other thread, i.e. actors. But built into the language, just completely impossible to have those problems. It was eliminated. But no, it didn't get evangelistic mindshare. It didn't get developer mindshare. You could view it as a lack of features because people seem to want generics. Perhaps too radically simple. Remember, I went back at the start and I focused on the fact that Java took stuff away from C++. And in many ways, that's exactly what Phantom did. It looked at Java and it took lots of stuff away before adding on some new stuff. But no, it wasn't going to be the next big JVM language. It was perhaps the closest we had. So this is my solution back then, backwards incompatible Java. What if we basically made a version of Java that was incompatible, which we fitted on all these lovely things? And why couldn't that be Java 8? Maybe it could have been. What did I do? I correctly predicted that those languages were not going to be a big language. I said that Java would be the next big Java. Kind of was. But no, I didn't get the incompatibility right. Amazingly, the smart people in charge of Java have managed to find a way to extend the language sufficiently without breaking compatibility. I think at some point, perhaps, it will get broken, but maybe not. So what about Kotlin? The lovely elephant in the room? Well, that's what I was looking at in 2010. There's Kotlin. So it came along after the talk, but here's where it gets harsh. It was a practical mainstream IDE first language. In many, many ways, it was exactly what I described. If you actually look through the slides, read through everything I just said, Kotlin pretty much is a darn close match to it. It was created after the boom, so it could learn a bit from Scala, learn a bit from the others. But if 1.0 wasn't until 6 years after Scala. So you see, here's the timeline, and that was the window of opportunity. That is the point in time we can look at with hindsight and say, that's the moment when people were looking at other languages and were probably willing to adopt it. If Kotlin had been 1.0 by the end of 2012, we might all be writing Kotlin now. Now, I know that won't please Kotlin supporters, but that's my take on it, that it was fundamentally after the moment at which it could have been, that Java 8 killed that opportunity. Because with Java 8, people had that view that Java was moving forward again. They had lambdas to play with. They felt positive about Java again, even though it took years and years and years to get to Java 9. So those were the things Kotlin fixed, loads of them, except again, sadly, that's now in Java. That's now in Java. That's now in Java. Now in Java. Coming to Java soon. Coming to Java soon. Even the next one might potentially come to Java soon. So Java has closed that gap to Kotlin. And I do see it sometimes that people compare Scala or Kotlin to Java 8. That's nonsense, right? You need to be comparing those languages to Java, the latest version. There'll always be things Kotlin has, but now there are things that Java has which Kotlin doesn't. So I failed to predict Kotlin. I couldn't quite see into the future. So what can we learn? Well, Java has grown a lot. There's lots of features out there which we've added in. There's var, there's pattern matching, you've got switch expressions, records, text blocks, field classes, virtual threads. That's just a selection of the features that have been added in. The Java developers, Oracle, putting that money in, have added a lot. Can things still be learned? Well, of course. Harsh on the screen there. But yes, I do feel that what Java learned from Scala was, here's an example of a language that did things a certain way that fitted for their ecosystem and fitted for their design, but it helped Java understand, it helped the language designers understand that's not how you should do it in Java. I do think this would fit well into Java. So imagine we were writing a record to represent a date and a record to represent a time, as expected, and then we got this record which combines those two things in a date time. Now, today, you have to write the second line from the bottom, date time dot date dot year, in order to get hold of the year. But imagine there was a feature export that could take the methods from an instance variable and promote them to the class that you're currently in. I think that would be useful, particularly with records. So yes, I do think that could come. Can Java learn from Kotlin? Well, yes, it already has. It's stolen various features, as we know. What's left? Maybe it doesn't fit. So named arguments. Hard to add. It's tricky in backwards compatibility terms. Do we want to drop braces? No, I don't think so, personally. Trailing lambdas? I don't see that happening. Just doesn't really fit Java. Function types were already rejected, properties already rejected, operator overloading. I think when we get value types, we'll probably have to have some form of operator overloading in Java, because if you can write your own values, you want to be able to have operators to go with them. Here's a couple of things that could migrate though. I reckon default method arguments could migrate from Kotlin to Java. Fundamentally, it's just basically saying, here's some default values for some of the arguments in the method, and you can omit those. Right? This isn't rocket science, right? That just generates 3 methods by the compiler, and then you can use any of those 3 methods. I don't think this clashes in the same way with method resolution, because it's fundamentally just generating code you could have written yourself. This is an interesting one. So Kotlin has a proposal under static scope projection reference. Scala's done similar things with its companion objects. The idea here being that you'd like to be able to refer to a static method on a class, but as though it was an instance method. That's kind of what you do with factories. Now, some of this has been addressed with lambdas, but I still think there's a case for it. So the concept here, plenty of other syntaxes would exist, that you can statically implement an interface. So parsable is a normal interface with normal methods, but what the compiler does is it generates a shim, generates a conversion class that routes any calls to the interface to the static method instead of to the instance method, which allows you to treat the static methods as though they were an instance. I think there are cases where that would be useful in Java. Can it learn from Phantom? Well, not really, because it was such a clean sheet. It has, its ideas are so different that it doesn't really fit with Java. But this would be great. So this is Phantom code. There are lots of different literals, like lots of them. A URI literal, a range literal, a duration literal, maps and lists. I do think when you get value types, you want to be able to have user-defined literals. If you can have user-defined value types, you need to be able to create those easily. So user-defined literals make sense. So this is my sketching out of how that might look. The idea is that you define your method to take in a strliteral, which is a special type, a bit like the str template class that they're discussing at the moment for templating in Java. So something that the compiler knows about and can actually do stuff at compile time with. And then using type inference and backticks, you can define your thing. So that's a date, but you check the date at compile time, making it into a literal. I think that's a perfectly achievable feature in Java. And what about this one, Joda to Java? So this is the feature which I think hasn't been in any of these languages really, but then Scala people would say it has with implicits. It's the idea that type conversion should be a language feature. So an awful lot of enterprise code is taking data from here to here with some type conversions. Like, we do it all the time. We write whole libraries to deal with it, where we write some bean manipulation rules that send it from one place to another. What if that was part of the language? I've always thought that was just an obvious addition to the language. Fundamentally, you just require a pair of methods that allow you to convert both ways. It doesn't have to convert both ways. It'd be nice if you did. Mark them as being converter methods, and then have some syntax that allows the compiler to say, I can do that conversion. But don't make it disappear completely like implicits in Scala. Make it visible. So here I'm saying, what if there was the wiggle? So I'm basically saying at the point on the last line is a leap year, but the method isLeap takes in a date, and I've got a local date. So the wiggle will convert from from local date to date in order to invoke the method. And it's using type inference to do that. And that matches with an awful lot of stuff we do, where we're converting from string to object, or we're converting from one type of object to an old type of object, a legacy one. There's all sorts of cases when we do type conversion like that. So there we go. Java did win, right? I could have shown other diagrams from all sorts of other sources, but fundamentally, the Java line is a heck of a lot higher than the other lines. If you look at the other lines in more detail, we can see that Scala is perhaps on a slightly going down trend. Kotlin is definitely on a slightly upward trend, but perhaps peaking, perhaps going flat now. But I wouldn't read too much into those. We're talking about small numbers here. I don't think that's necessarily enough of a trend to be able to prove that. But those two languages are definitely clear of Scala and Groovy. Are clear of Clojure and Groovy. So yeah, Java won. Kotlin is and isn't the next big JVM language. It did meet the goals I laid out. It has the pragmatic approach. It has the pragmatic style. But I believe, fundamentally, it was too late to replace Java. Does that mean it's not useful? No, of course not. It's got its niche. It's out there. It's widely in use. It's popular. Nothing wrong with it. But replacing Java is a different challenge. So yeah, Java struck back, and Java 8 was the key to that. If Java 8 hadn't come out with lambdas, things would look very different. And some final thoughts, that language design needs to focus on productivity. That giant group of people in that yellow circle are the people who want productivity out of their language. They're not actually that obsessed about type systems or static typing or any of the other zillion features we just outlined. So long as it's productive for them, that's what they're interested in. Sometimes it's not about what you add, sometimes it's about what you remove in a language. I think sometimes language designers need to keep that thought in their head. And that Java 22 is a lot more advanced than Java 8. So if you are doing comparisons, make sure you're comparing to the latest and greatest and not what you think Java is. So that is my hostage to fortune for the next 15 years. So when I come back in 15 years' time, just before I retire, that Java will still be the dominant JVM language. Will it be the dominant language for enterprise? That's a different question. But if another language is productive for you, go ahead. It's great. And the force will always be with you. Thank you. So I am out of time, but if you have any questions or any thoughts or comments, feel free to tweet or come and berate me now. Thank you.